there, my fellow curious minds, and welcome back to Tech Advantage, the podcast where we talk about technology, business, and personal growth. I'm your host, Tondow Abraham, co-founder and head of technologies at BlueMind, and today we're going to talk about a few things. Before we dive into the episode, I want to acknowledge that it's been quite a while I put out an episode, and if you've been following, you'd notice some gaps. I've come to realize that stepping back is also a part of growth, and after such gaps, I don't just want to talk, I want to share things that actually matter. Today's conversation, I want to talk about what separates developers from engineers, engineers from builders, and builders from people who actually create real impacts. And that is this, the ability to think in systems. Now, most people in tech today focus on frameworks, tools, trends, and whatever is currently hot. But real building has never been about trends. It's about what works consistently under pressure. And we all know that that requires a completely different way of thinking. The illusion most developers live in is quite an uncomfortable truth. Most developers today are not building systems. They're just assembling codes, and there's a difference because when you've been trained through tutorials, boot camps, some short form of content, and things like build this in 10 minutes videos, you subconsciously develop a mindset that says, if I can make it work, I've done my job. But in the real world, it works is just the beginning of the problem. Because in production, things break, users behave unpredictably, systems get overloaded, dependencies fail, networks become unreliable, and suddenly, that clean code you wrote in isolation is now a part of a messy, interconnected system. This is where most developers get exposed, and not because they're not smart, but because they've never trained to think beyond the code. So now we're moving into what system thinking actually means. So let's define it clearly. System thinking is about seeing beyond individual piece of code and understanding how everything connects, behaves, and evolves over time. It's not about writing more codes. It's about understanding how data flows, how the components interact, where failure can occur, how performances scales, and also how decisions today affect systems tomorrow. Let's make a practical example. Now, if we're talking about a login system, a beginner sees input fields, validation, authentication, success or failure, and the basic things that revolve around such a system. But a builder sees something completely different. A builder would rather question things like, where is the data stored? Is the database indexed properly? How are the passwords secured? We're talking about hashing and salting. What happens under brute force attacks? Is there rate limiting? What happens if the authentication service goes down? Do we cache sessions? How do we manage tokens? What happens across devices? And all of these technical questions, it could even extend further to questions like what happens when 100 users log in? Then we talk 1,000, 10,000. And what about peak traffic? Now you're not coding anymore. You're designing behavior. You're designing relevance. You're designing resilience. And that is what system thinking is. So let's go deeper into where most developers get it wrong. First off, we have overvaluing speed over structure. A lot of developers pride themselves on how fast they can build. And yes, speed is king, but speed without structure creates fragile systems. You see this a lot in early stage projects where everything works initially, but as feature grows, things start breaking, bugs become harder to trace, and the changes affect unrelated parts. That's not bad luck. That's just lack of system thinking. Secondly, we have tight coupling everywhere. And that's another major issue. Everything depends on everything. So when you change one thing, you unintentionally break 5 other things. This happens when developers think in isolation instead of flow. Thirdly, we have no failure planning. This is a big one because most developers assume everything will work, but real systems are designed around failure. Good builders ask, what if this fails? What if this is slow? What if this returns incorrect data? Because failure is not an exception, it's a guarantee. So we ought to shift our mindset and stop asking questions like, how do I build this feature? And start asking, how does this feature behave inside a system? That one shift changes everything because now you're thinking in interactions, dependencies, trade-offs, and long-term consequences. Here are some real-world lessons for real builders. When you're working on actual products, especially in environments like startup, clients, projects, production systems, you realize very quickly that building is not the hard part. Maintaining is. Anyone can write code that works today, but few people can design a system that works in 6 months. And that's where reputation is built, because in the real world, clients don't care about your code elegance and users don't care about your stack. All they care about is, does it work reliably? And that's it. Now, here's how you can actually develop system thinking. First, start thinking in flow. Every feature has a journey, and you ought to follow it. It could be a sequence like user, then interface, then API, then server, then database, responses, and then UI. If you can't explain that flow clearly, you don't fully understand what you built. Secondly, build real systems, not just projects. There's a difference. Projects are controlled and systems are unpredictable. Build things where real users interact, real data flows, and real failure occurs. That's where growth happens. Thirdly, study architecture and not just code. Start exposing yourself to system design concepts, backend architecture, and distributed system, even at a basic level, because that's where the depth comes from. Fourthly, debug more than you build. This might sound strange, but debugging is one of the fastest ways to develop system thinking. Because when something breaks, you're forced to trace cause and effects, data flow, dependencies, and that's real learning. And finally, think in trade-offs. Every decision in engineering has a trade-off. Speed for scalability, simplicity for flexibility, even performance for cost. There is just no perfect system, only well understood decisions regarding trade-offs. At the end of the day, here's what I want you to understand. The future of your career in tech will not be defined by how many languages you know or your tech stack and all of that stuff. It will be defined by how you understand systems, because tools change, frameworks changes, trends change. But systems are what power everything, and the people who understand them are the ones who build things that last. The whole essence of this entire episode is the definition of scalability. So here's my challenge for you. The next time you're building anything, don't just focus on making it work. Ask yourself, how does this scale? What can break? How does this interact with other parts? Can this survive real usage? And these questions is how you grow. That's how you stand out and how you become a real builder. Thank you for listening to Tech Advantage thus far. And if this episode resonates with you or have given you value, please do share with anyone you'd like to give good tech knowledge to. Leave us a rating and follow the podcast wherever you get your podcast from. And as always, technology is your advantage.